Okay, today we are going to identify and use reflections in the plane following given definitions. Okay, so a reflection is a transformation across a line called a line of reflection, so that the line of reflection is the perpendicular bisector for each segment, joining each point and its image. Okay, that's a lot. Basically what that means is however far away point A was from the line of reflection, its image, A prime, has to be the same distance, and that distance has to be perpendicular to our line of reflection. Like you wouldn't want to go the same distance off this way, right? That wouldn't be a reflection. That doesn't make sense. Okay, so we're going to just want to make sure that it's perpendicular to the line of reflection. The pre-image and the image must be equidistant. Okay, that's a big word, but if you break it apart, equa looks like equal, okay? And you can see the word distance in distant. Equal distance. You can see that these are marked as congruent, and we know that segments that are congruent have the same measure. So they are equidistant from the line of reflection. Okay, recall that a reflection is a transformation that moves a figure, our pre-image, by flipping it across the line. The reflected figure is called the image. A reflection is an isometry, so the image is always congruent to the pre-image. Remember that in an isometry, we are preserving angle measure and we're preserving all the segment lengths. Okay, so here we have some rules started for us. We're going to try and fill in the rules. I like to think of these with real numbers, and it helps my brain figure out what the rule should be. So this P kind of looks to me like the point 1, 3 maybe. Okay, so if I reflect P, 1, 3, in the x-axis, which is this line right here, this is the line y equals 0, that's the x-axis. Notice that the x does not change. The x is still 1, right? It's still 1 right from the y-axis, but the y changes to a -3. Okay, so the x stays the same and the y goes opposite of what it was. So that's our rule for reflecting in the x-axis. Now, if we reflect in the y-axis instead, this is the line x equals 0. Look what happens. This to me looks like, what, 2, 3? Okay, so P is at 2, 3. If I reflect 2, 3 in the y-axis, my y value is stayed the same. Look, I'm at the same height. So my y stays 3, but my x is now opposite. It changed to -2. Okay, so for the rule, I'm just going to change the sign on my x coordinate and then I'm going to keep my y. Okay, this is a fun one. Now we are reflecting across a different line. We're reflecting across the line y equals x. This you might recognize from Algebra 1 as your linear parent function. Okay. In order to get the points that are on that line, you want to think of x's and y's that are equal to each other, right? So if my x is -3, my y has to be -3 because they have to be equal. They have to be the same. If my x is -2, my y is -2. -1, -1, 0, 0, 1, 1, 2, 2, and so on. So that's this line right here. Boop, 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 boop. All right, so I'm looking at point P. This one looks like 1, 4. Maybe 1, 3. 1, 4? I don't know. 1, 4, let's say. Okay, so if I reflect that in the line y equals x to this point here, p prime, look, now I'm at 1, 2, 3, 4, 1. Okay, my x and y changed spots. My x became my y, and my y became my x. Okay, last but not least, here we've got the line y equals negative x. It's just like our linear parent, except that it's got a negative slope. Okay, so it itself is a reflection in the x-axis. That's fun. So we'll start with p. This looks like 4, 1. Okay, if I reflect it in the line y equals negative x, you can see that I've got a point negative 1, negative 4. So my x and y traded spots, and they both change signs to opposites. So this is going to be the opposite of y and the opposite of x. So they switch spots and they change signs. Okay. All right, now we have to reflect the figure with the given vertices across the given line. So we're starting with a triangle with these vertices. So point x is at 2, negative 1. So go ahead and start graphing with me. That's x. Y is at negative 4, negative 3. If I'm graphing too fast, you can pause me and catch up. Z is at 3, 2. Okay, I'm going to connect my points and make a triangle. Okay. And it says that we have to reflect it in the x-axis. The x-axis is this horizontal line right here. If it's a horizontal line, remember it has a slope of 0, and it's a y equals equation. This is the line y equals 0. Okay, so the rule is that we're going to keep our x value and make our y the opposite. So here, I'll write the rule. It says if it's xy, it's going to map to keep the x, change the sign on the y. So my triangle is going to change to keep the x coordinate and change the sign on the y. So negative 1 turns positive 1. That's for x prime. Okay, for y prime, I'm going to keep the negative 4, change the sign on the negative 3. For my z prime, I'll keep the 3, change the sign on the 2. Okay, so x prime will be up here at 2, 1. Okay, y prime will be at negative 4, positive 3 instead of negative 3. And z prime will be at 3, negative 2. Oops, that's negative 3, negative 2. Okay, go ahead and connect your points. And there you have a beautiful little reflection in the x-axis. Okay, now we're going to reflect our figure in the y-axis. So we're going to start with our same starting points. Doesn't really matter what order we graph them in. Here is x, and y is down here. Oops. Okay, so let's draw in our line of reflection. This time we're going to reflect in the y-axis. Okay, this is the line x equals 0. Okay, it's a vertical line. It has undefined slope, and its equation is x equals 0. So our rule for reflecting in the y-axis is that we're going to keep our y value the same because we don't want the y value to go up or down. We want to keep it. And we're going to change the sign on our x coordinate. So that'll be x, y maps to change the sign on the x but keep the y. Okay, so let's write down those points really quick. So our x prime will be change the sign on the 2, keep the -1. Y prime will be keep the -4, change the sign on the -3 to a +3, and z prime will be keep the 3, change the +2 to a -2. Okay, so z prime ends up here. X prime, whoops, I'm reflecting in x again. Hold on, back up. Okay, we're going to reflect in the y-axis. Sorry, guys. Okay, so z prime is over here. Wait a minute. Oh, I did z backwards. I think I got the rest of them right. No, I did them all backwards. I got it all messed up. Oh, shoot. Well, guys, I can't figure out how to go back and fix it, so I'm just going to let you laugh at me. Okay, I did the first one right for x prime, but these two I messed up. I started doing the rule for reflecting over the x-axis again. So I'm going to need you guys to help me go back and change them. So we should have kept a -3. Whoops. We should have kept a -3 because we're keeping the y, and we should have changed the sign on the x. So this should be a +4 for y prime. And then for z, we should have kept the +2 and changed the +3 to a -3. Sorry that I got those backwards. I don't know what I was doing. Okay, so x goes here, that's x prime, and then y ends up over here, that's y prime. Okay, just connect your points to make your image. Okay, and that's it. Okay. So it turns out that the x-axis and the y-axis aren't the only lines that we can reflect in. Okay, here we're going to reflect in the lines x equals 1 and y equals 1. So if it's x equals 1, that's going to be a vertical line with undefined slope. Okay, wherever x is 1. So if we think about all the places where the x coordinate is 1, here's 1, 1. Here's 1, 2. 1, 3. 1, 3.5. 1, 3 3/4. Right? All of these infinite points, if we connect them, make up the line x equals 1. So you can go ahead and just dash that line in. Okay, that's our line of reflection. And then we'll go ahead and graph our, what is it, a rectangle? Okay, so S is at 3, 4. That's here. T is at 3, 1. U is at -2, +1. And V is at -2, +4. So if yours does not look very rectangular, go back and fix it. Okay, there's my little rectangle. Now we have to reflect this across the line, x equals 1. So we're going to keep the y coordinates, but we're going to make the x's the opposite, but we're shifted right 1. So if I am, let me see, what's the best way to do this? Do you see how v is 3 units away from the line of reflection? Okay, well, I'm going to make him 3 units away on the opposite side. This is v prime. Okay, u is also 3 units away from the line of reflection. So I'm going to put him 3 units away on the opposite side, u prime. Okay, s is only 2 units away, so I'm going to put s prime just 2 units away on the opposite side. Same with t. Here's t prime. Okay, connect my points. Boop, 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 boop. Okay, and that is my reflection in the line x equals 1. Okay, now we're going to reflect in y equals 1. So if x equals 1 was a vertical line, y equals 1 is definitely going to be a horizontal line. Some of you might remember Hoy and Bucks. Others are probably so traumatized by Hoy and Bucks that you forgot. All right, so let's start with our rectangle again. Here's V, S, T, and U. And this time we're going to reflect in the line y equals 1. So if my points are starting on the line of reflection itself, they don't move. They are sort of like the hinges when it flips. They're not going to move. They're just going to stay where they are. So u maps to u prime, but u prime is just in the same spot u was. Same with t and t prime. Okay, they're not going to move. Okay, v was 3 units above, so it's going to drop 3 units below. Okay, that's v prime. S was 3 units above, S is going to drop 3 units below to be S prime. And I forgot to draw my rectangle. So we'll just draw them both at the same time. Okay. Next. So this time we have to reflect our figure in the line y equals x. So if you're trying to think of points for the line y equals x, you just have to make the x's and y's equal to each other. So if I start with -2, my y has to be -2. If I have a -1 for x, my y is -1. 0, 0, 1, 1, 2, 2, right? You can extend that infinitely in both directions. So it's this line right here. That's our linear parent. All right, let's get our triangle on here. Okay, so point R is at -2, 2. S is at 5, 0. And T is at 3, -1. Okay, connect your points. Okay, so let's remind ourselves what the rule is for reflecting in the line y equals x. If you go back to the front, remember that if I reflect in the line y equals x, my x and y just switch. They just flip-flop and trade places. Okay, so that's what we're going to do. Oops, one more. Let's write that rule real quick. X, y, maps to y, x. Okay, so my r prime will be 2, -2. My s prime will be 0, 5. T prime will be -1, 3. Okay, so 2, -2. That's here. This is r prime. Okay, 0, 5. That's all the way up here. That's s prime. Okay, and then t prime will be at 3, -1. 3, -1. What did I do? No, -1, 3. Good grief. Here's t prime. Okay, graph much? It's kind of pretty. Okay, now also on the front was our rule for reflecting in the line y equals -x. Let's go back and look at that one. So not only did our x and y change spots, they also changed signs. So they changed spots and changed signs. So let's write that rule. X, y maps to y, x, but they're opposite, so now they're negative. Okay. Let's figure out what these points should be. R prime, I'm going to switch them and change their signs. So if I move the -2 to here, to the y spot, okay, and then I make it positive, don't I just get a 2? Okay, and if I move the +2 to the x spot and then change its sign, don't I just get a -2? Interesting. Okay, and then s prime, change their spots. So the 0 first, 5 second, make them both opposite. The opposite of 0 is 0, and then make that a -5. And then t prime, change their spots, change their signs, +1, -3. Okay, so my original triangle, get that up on here, is this one. Oops, not there, here. Okay, so this is T, this is S, and this is R. Okay, so now my line of reflection is this line. Y equals the opposite of X. It has a negative slope. Now, remember how our R ended up in the same place? Our R prime is in the same place as R. It's because it's on the line of reflection. So it didn't actually move. All right, so S prime is at 0, -5. That's down here. And T prime is at 1, -3. It's T prime, S prime, R prime just hanging out on R. Okay, draw in your triangle. Make sure everything's labeled. It should kind of look like a paper airplane. Okay, let's look at this one. I think this is going to be the last one that we do. I don't think you need the very last example. Okay, here we have figure ABCDE, and we have to use the graph of the transformation to answer these questions. Okay, so this is our pre-image. And we have to find the image. Okay, and this is the important thing you need to remember, so write this down. The order matters. Order matters. Because the order that you list the points in is telling what is mapping to what. So if we look at the figure and we find point A, we can't just start with H because A does not map to H. If you look at the figure, you can tell that A maps to F. Okay, so when I write my image, I'm going to make sure that I start with F because the pre-image starts with A. Okay. Okay, next we look at B. B is mapping to G. So that's the next thing that has to go right after the F. Okay, C maps to point H. D maps to point I. And point E, well, it kind of maps to itself, but they've got another letter there, it's J. Maps to J. Okay, so what is this that we've done here? It's not a rotation, it's not a translation, it is a reflection. And then it also says that we have to describe it. So what line did we reflect in? Did we reflect in the line y equals x? Did we reflect in the y-axis? Nope, nope. We reflected in the x-axis. In x-axis. Okay, also known as the line y equals 0. Okay, next we have to name two sides with the same measure. So if I look at segment AB, okay, its congruent counterpart in the image would be FG. So I'm naming the sides. I'm not talking about their lengths. I'm talking about their names. So I have to name them as segments. So this would be AB. And I want to say that it's congruent to, what is that, FG. Okay, now I have to name two angles with the same measure. I like these two right here. Look at those. Okay, so I have to say their names. So I'm going to say angle C is congruent to angle H. All right, we want the coordinates, that should be an S, coordinates of the pre-image of point G. Oh, goodness gracious. Okay, so G is this guy. Well, we got G from B. So what are the coordinates of B? That looks like 3, 4. So we have to name them. So that would be B, open parentheses, 3, 4. Now we have to do the same thing for the image of point A. So A mapped to F. So we know it has to be point F. And F's coordinates are 1, -2. 1, -2. I think that's it. I think that's the end. You survived.